Thanks, Steve. Hi, everyone. My name is Marco Cavallo, and today I'm going to talk about Dataspace, a work that I did in collaboration with my former colleagues at IBM Research. In this presentation, you're also going to see a small red avatar that, in an ideal world, is supposed to be me in a chibi version. I like Iron Man, if that was not clear. So I'm going to start with a brief introduction about immersive environments. So I would say for the past 30 years, we have seen an exponential increase in the amount and in the complexity of the data that has been digitally collected and stored. And this has challenged the researchers in order to create visualization instruments to make sense of this data that sometimes we cannot easily understand by simply looking at it on our normal laptop display. So probably most of you remember the famous example from Cave that was presented in 1992. Cave is pretty much a cubic environment on which you have projections on 6 sides of this cube. And it was mostly used for 3D graphics with stereoscopy, mostly for architecture, molecular data, scientific data, and astronomy. In the early 2000s, there was a drop in the price of LCD panels. So what people did was to create the so-called power walls, or tile display walls. And the focus here went into improving, increasing the resolution of these environments. Later on, there were improvements on both sides, and there were other environments such as Cave 2 that try to have a better trade-off between 2D and 3D rendering, but pretty much there were many limitations. When I was working in Chicago at the Electronic Visualization Laboratory, we had a Cave 2, and I always wanted to have one at home. However, it was $1 million. So I was not able to build it. I was not able because it was too complex, too expensive, and maintenance and other problems were too high. So years later, I was able to collaborate at the creation of this environment called Dataspace, where we pretty much continue the legacy of Cave 2. But the idea here is that the concept of hybrid reality, in this sense, it is to have simultaneously 2D high-resolution statistical information that is very good for statistical analysis and data visualization and charts, combined with 3D graphics, in this case given by AR headsets. In our case, Microsoft HoloLens. And this gives you a more flexible data immersion, meaning that you can go in all the range from having a VR headset to having a sort of power wall. Let's go quickly to how the system is composed. So the physical configuration is actually 15 4K displays that, interestingly, are connected to 15 7 degrees of freedom robotic arms. This means that these screens can actually be reconfigured into space. So for instance, I could say, oh, bring this content closer to me. And the robot is going to move the physical screen next to me. They also have what we call compliance mode. That means that I can physically move the content. So if I have a chart, I can actually push the chart away from me and move the robot. We have a central table that we envision for collaboration and putting insights together as a team, because the idea is that we are building a sort of a meeting room for the future. And the table has projections originated by 2 HD projectors. We have what we call perception system that is composed by 8 Kinect V2 sensors attached to the ceiling that allow us to understand which interactions are performed on the table and around the environment. We have the typical spatial audio system, and we have 4 microphones that allow us to identify the source and directionality of speech. As I said earlier, the 2D the screens are used for displaying high resolution 2D information, whereas we use the HoloLens devices for displaying the 3D information that generally appears on top of the central table. So the system is, I would say, rather modular. It's composed by a robot controller that pretty much knows the real-time position of all the robots and thus the monitors, and also have some safety measures to avoid people being hit by robots. we have a display subsystem that controls which content goes where. And so we also know in a global coordinate system which content is located where. We have audio lighting system, and also what we call the perception, that is the kinects, that fundamentally create a giant point cloud of the environment, which we align actually with the mesh generated through SLAM by the HoloLenses. So all of this information is aligned in a virtual model of the environment that allows us to know where users are, where the lights are, where the content is situated. And this helps in many different cases, such as interaction, or as you can see in the picture there, we can do proper lighting conditions for the virtual objects. Talking about interactions, so we have this idea that when you perform an action, you want to do it in a natural way, and you don't have to be restricted by a specific type of interaction. So if you want to use voice, you can use voice. If you want to use touch, you can use touch. If you want to use a gesture, you can use a gesture. And this is going to depend on the person, on the context, and on the type of data. So our idea is to support all types of interaction. The interesting thing here is that interactions are also contextual interactions, because as I said earlier, we know the relative positions of users, content, and screens. So I could say, oh, I don't need this screen anymore, pull it up, and then it's going to put these things together and identify that the screen is the one behind me, and then move the screen up. Similarly, I could say, oh, I'm working on this part of the dataspace, and I'm doing something here, send it to my friend that's working on the other side of the space, and then we can either decide whether to move the physical screen or to actually shift the content from here to the screen next to my colleague. And also, thanks to the combination of microphones and the HoloLenses, we also know which person is speaking or performing an action. So for instance, if I want to take control over the discussion during a meeting, I can raise my hand, a light is going to illuminate me, and then all the content is going to be reoriented towards me, because in the end, it's a circular design, so we can shift and rotate the content. So we did some applications in order to demonstrate the usefulness of this environment. The first one was a classical one. It was about exploratory data analysis. This is an application that we call Immersive Insights. The idea here is that we combine high resolution statistical information and charts with I would say spatial information about clustering and dimensionality reductions that generally happens on top of the table. And the interesting part here is that you can simultaneously look at the 3D information and the 2D statistical information. Another example, on the right, we have a data center. You're interested in seeing the faults that happen in a data center, but at the same time, sometimes you want to see the spatial configuration of the data center. Say, oh, the ventilation was broken here, so it increased the temperature in this area of the data center, and then this machine broke due to overheating. We have another use case connected to healthcare in this case. And in this specific, we call it the HoloBrain. In this case, we have a remote hospital sending data that is actually analyzed by experts in the data space used as a control room. And then feedback is collected and is sent back to the hospital. The final case is sort of a classical one where you have different types of information about drugs, molecules, and chemistry, but also you want to have the 3D structure of a molecule. And to make it short here, I would say that pretty much here we are showing how Dataspace can address flexibly and simultaneously having both high resolution to the information and 3D data in a collaborative setting. To close, so despite the environment itself is modular, so you can sort of decrease the price, it is still very hard to build. As a partial solution, what we do is to, since we have a virtual 3D dynamic model of the environment, we actually use to build a VR clone of the data space. And if I use the VR version of the environment, I can actually move, for instance, robots in real time. So if I move a robot in the VR environment, the people in the physical data space are going to see the robot moving. Conversely, the people in the physical space are going to see me through augmented reality as an avatar, like you can see in the picture below. So the next things we're interested in trying to understand better how we can use the reconfigurability of the monitors. How can that change over the same application? We demonstrated that it is useful to change the configuration of screens during different use cases, but the question is it useful during the same application? And then we want to know more about user behavior. So like, how do you get control of like a speech when there's multiple people doing multiple things? How do you move content? Is it useful to actually physically move the robots? And how, if you have multiple people doing different things, how do you converge to collective insights? And this was it. So if you need content information, that is me. I recently changed company. So in that case, you can contact the current manager of the Dataspace, that is Mark Podlaseck. And feel free to ask questions. Meanwhile, I will leave a video as a background so that you can see. This is the first example that was Immersive Insights. And thanks for watching.
So this seems like a very impressive environment, and I was noticing that in the configurations you discussed in the paper and showed here, they seem to be relatively simple. Screens are either down or they're up, and they can move a little closer or a little further away. And I'm not sure how much volume those robots can move in. It looks like they have quite a lot of full degrees of freedom. Have you thought about configurations where there might be, for example, a panel in front of me like this and another one up at an angle, more like maybe a control console, let's say, that wasn't simply planar?
Gotcha. So thanks for the question. It's actually one of the big questions that we are asking ourselves. So the current configurations that we use, we have some that are more dedicated towards doing, how to say, meeting or like a conference meeting, and some other ones that are more oriented towards having a real application. So for instance, if I have a normal conference, I want to say, okay, I'm presenting stuff here, but people are sitting in a circle, so I can have, I would say, symmetrical configuration where you have multiple screens in landscape mode that sort of mirror the same thing that is presented. We can have a sort of VR mode where all the screens go close to each other and create a circle around you that we call immersion mode. However, we don't have enough coverage to do something like a cave would do. So this is sort of something that we cannot have a full 360 content around us. We have lots of configurations that have what we call triptychs. So let's say that they have larger content, like in that case. In Immersive Insights, you can say, oh, I have too many variables, like just add a screen. And then a screen is going to come next to the ones, and then it's going to touch, like you can see in the table in the center. And they can attach to each other automatically to fill the space. However, you will say, how scalable is that? Like, if you have, I don't know, 10 features, that is fine. If you have 1 million features, that doesn't scale. Also, to answer the last part of your questions, they can rotate in space, but they have a limited moving capability. So they cannot move too far away. So you actually have a limit in the possible configurations that you can have.
Thank you. So one more question before we go into our everyone gets to ask questions. Oh, I do see a person actually with a microphone. Yeah. So I will yield to you. Please ask.
How often did people actually switch between using the HoloLens and these 4K panels? Because, I mean, in principle, you could also show these panels in the HoloLens, right? So how did they make use of the physical surface of these displays? Or is it more the high resolution of them?
Yeah, so that's a great question. So fundamentally, we have the two extremes, right? We have the cave environment where you have like this massive environment around you, and then you could say, well, why don't I just use like my Oculus or HTC. The problem arises in when you're doing data visualization or like medical imaging or something where you really need high resolution stuff. Probably with like, how to say, with the improvement of displays for headsets, the problem is going to be less. But at the moment, if you try to do certain visualizations in the HoloLens or in an VR device, it's not going to look well, and you won't be able to understand the same amount of information. So having both, in this case, is still convenient. To answer about how much they use the HoloLens, it actually depends a lot on if they start with the HoloLens or if they start with the HoloLens on the table and then they actually wear it. Unluckily, what I noticed is that despite I could live 24 hours a day with a HoloLens on my head, people do not like wearing a HoloLens for more than 5 to 10 minutes. So in that sense, I realized that certain people tend to keep it for a long time, but other people don't like to wear it, especially if they are not like VR enthusiasts like maybe we are. I've seen people just putting it on for 3 minutes and say, okay, I've had enough of this. So it's still something we need to work on.
So one other thought, and that's that with the HoloLens and those very large high-res displays, which clearly are much wider field of view, you could use the HoloLens to add in specific information that was going to be private, or more or less so, to the individual people. So you and I can look at the same physical display, see different things without my seeing your stuff because I'm not allowed to or because I don't want to see the clutter. Did you do any of that?
We have it in progress, but not. We are doing that, but not for like this paper. It's going to be a future paper. But yeah, and another thing is personalizing the experience, because generally when you use a Cave 2, for instance, there is a person that gives the perspective to all the other people, and this is what everyone is going to see. In this case, you can actually personalize it, and everyone can see their own thing. You can have privacy levels. You can have, I'm interested in seeing certain things more than other people, or there's lots of things we can do in that sense.
Okay. Thank you very much. Let's thank the speaker.